All right, so the first one was a limit problem. So this is limit as x goes to 0 of this function. All right, so the first thing you want to do is try to plug in 0. But if you do that in the numerator, you get 0 plus 0. Sine of 0 would be 0. And in the denominator, you get 0 minus 0. So this goes to form 0 over 0, which means we're allowed to do L'Hopital's rule. So we're going to take the derivative of the numerator and the denominator separately. So for the numerator, that would be 7 plus derivative of sine is cosine. And then down here, derivative of 2x squared, that would be 4x minus, all right, derivative of sine is cosine, so that'll be cosine of 3x, and we have to multiply on a 3 for the chain rule. So 3 cosine 3x. So we did the derivatives, and now we're going to plug in 0 and see what we get. So in the numerator, 7 plus cosine of 0. Let me pull out my unit circle here. Here is 0 pi. Cosine is the x part of that, so that would be 1. So cosine of 0 is 1. And then down here, we're going to have 0 minus. All right, cosine of 0 is 1 times 3 would be 3. And so that would be 8 over negative 3. But you can actually stop here. You don't have to simplify it down. You could have stopped right here. Once you get an answer, you don't have to go any further. Right, so for the second and third ones, we're just finding a derivative. I'm sorry, I can't write and talk at the same time here. Except it's implicit differentiation because the x's and y's are all jumbled up. So we're going to do the derivative of each term, and then we'll have to do algebra to get dy dx by itself. So derivative of x squared, that's 2x plus, all right, and then exponential is itself, so I'm just going to copy that down. And then we have to chain on the derivative of 6y, which would be 6 dy dx. And then, hey guys, what is the derivative of 12? Because don't forget that you have to take the derivative of the other side too. So what is that derivative going to be? Good, awesome, 0. Just don't forget whenever it's just a number, when you have a constant, that's just going to be 0. All right, and then the rest of this is algebra. That's the derivative. We just have to get dy dx by itself. So I'm going to subtract over the 2x. And then we're going to divide by the 6e to the 6y. And you can just stop there. That's a perfectly good answer. I'm going to go one step further just because most people did, just so that you can check this with me. People reduced the 2/6, which would reduce to 1/3. But again, it's not necessary. In fact, I'd almost prefer you stop here because if you simplify and you mess it up, then you're going to lose points, so just hands off. All right, and then number 3 was the same thing. It was just find dy dx. So we're going to do the derivative of each term, and then we'll get dy dx by itself. So derivative of 3y is 3 dy dx. Derivative of x to the 5th, that will be 5x to the 4th. And then derivative of tangent of y, that is secant squared of y dy dx. Again, anytime you do a derivative of a term with a y in it, you need to put a dy dx. So what's a little tougher about this problem is I have 2 terms that have a dy dx in them. So I'm going to need to get them on the same side. So I'm going to subtract this over. And I'm sorry, I need to respond to somebody that wrote me something in the chat. Everybody just hold on one second. Okay. And then since those are now both on the same side, I'm going to factor out the dy dx. So it's greatest common factor. And then last step, we're going to divide all of that to the other side. So dy dx equals 5x to the fourth over 3 minus secant squared of y. Now I had some people move it the other direction, like they moved everything to the opposite sides of the equal sign. So if you did that, you would have gotten negative 5x to the fourth over secant squared of y minus 3, like the whole thing was backwards. Those are mathematically equivalent. So if you did this instead, that is totally correct as well. You just moved your stuff to the other side. All right, so while I'm writing out this one, let me ask you guys a question. For this one, it says write an equation. All right, so hey guys, what things do I need in order to write an equation? Good, awesome, point and slope. All right, cool, so I need a point and I need a slope. You guys rock. Thank you for typing to me. Make me not feel alone here. All right, so our point of tangency is x being -4. So that's gonna go here. And to get the y value, we're going to plug -4 in for x to the equation. So you just plug in x, you get y. It's a little bit more jumbled up than usual, but it's the same idea. We're going to plug in -4 for x. So this will be y squared minus 4y minus 16 equals -4. And then we're going to add over the 4 so that that all equals 0. What would that be? Minus 12. And then we're going to factor. We're going to get two answers, and I told you to keep the positive one. So one is going to be positive, one's going to be negative, and this is going to split 6 and 2. We'll have -6 plus 2. So this is going to give us y equals 6 and y equals -2, and we're going to keep the 6. All right, so that's the point. Now, slope comes from the derivative, so we're going to do the derivative of this and then plug in our point, all right? So derivative of y squared, that is 2y dy dx, plus, now this is a product rule, so it's going to be the first, x, derivative of y, which is dy dx, plus the second, which is y, times derivative of the first. So derivative of x is just 1. So that is our product rule for that. And then this derivative will just be +4. And then derivative of a constant is 0. And what most of you did is you rearranged this to get dy dx alone. There's nothing wrong with that, but my suggestion is go ahead and plug in these numbers right away because it's a lot easier to deal with numbers than it is variables. So I would just go ahead and plug those in just right away. So if y is 6, this is going to be 12 dy dx. And then x is -4, so -4 dy dx plus 6 plus 4. And so that already simplifies it down because now you have actual numbers to deal with. So 12 dy dx minus 4 dy dx, that's going to be 8 dy dx plus 10 equals 0. And so we're going to subtract the 10 and then divide by 8. Now you can leave it as -10/8, but if you want to reduce that, that would be -5/4. And so that is our slope. And then we just need to write our answer. So this is our point, this is our slope. It'll be y minus 6 equals -5/4 x plus 4. And if you want to know how the points worked out for that problem, I made it a point for plugging in the x value and then a point for solving for y. So it was 2 points for getting that. I made the derivative worth 3 because that's where all the calculus was. It was a point for this first part, a point for the product rule, and then a point for the +4 and the equals 0, because that's where all the calculus was in this problem. And then it was a point for getting the slope, and then it was a point for getting the answer. So basically a point for each thing that you did. All right, and then the last one, this is about a boy flying a kite. And so it's going to be a right triangle. So don't make fun of my drawing, but this is, the boy is down here, and then the kite is up here in the air. That's about the best drawing you're going to get out of me, all right? So it says he is pulling in the string at 8 feet per second. So this distance is changing. I need to label that with a variable. I'm going to call it y. You can call it whatever you want. A lot of you used r, which I think you were modeling it after the boat problem that we did in class. I think that was perfect. You can call it whatever you like, right? But he is pulling in the kite at 8 feet per second. So that's dy dt, and that's going to be negative. I had a lot of people miss the negative sign on that, so let me throw this question out to you. Why is that rate negative? Why would dy dt, or whatever you named it, why would that be negative? What is the reason for that? Yeah, good, perfect. It's being pulled in, or it's getting closer. We're pulling it down. Decreasing in distance. Good, all perfect answers. Nice job, guys. All right, perfect. All right. But that does need to be negative. Now the boy is standing a horizontal distance of 15 feet from the kite. He's not moving, so that is a constant 15 feet. I could have made him be running around. That would have made the problem more complicated if he was also moving, but he's standing still. So this 15 feet is constant. And we were being asked at what rate is the height of the kite changing? So if I call that x, again, you may have called it something different, that's fine. What we're being asked for is dx dt, and it should also be negative, because if you are reeling in a kite, you're pulling in the string, the kite's going to be going downwards. And now we have to pause at a certain moment because everything's moving. So at what time? And it says when the kite is 20 feet off the ground. So that's when x is 20 feet. All right, so the relationship between the variables, it's going to be Pythagorean theorem. So we'll have 15 squared, which is 225, plus x squared equals y squared. And then we're going to do the derivative. So, it was funny to me. I just want to bring this up to make sure it doesn't happen again. People generally didn't have an issue doing a 0 whenever it was a constant here. And then also in number 2 with this 12, people remembered to put a 0. But then when we did the derivative of this one, people forgot and left it 225. So just be really careful. That's a constant, so that is going to go away. So that derivative would just be 0. And then for x squared, it will be 2x dx dt, and then equals 2y dy dt. Again, every variable will be with respect to time in these related rate problems. And then the 2's will cancel, which you didn't have to do, but that kind of simplifies it. We'll get rid of those. And then we're going to plug everything in. So x is 20, and dx dt is what we're trying to find. So I'm going to leave that in there. Y I do not have, so we'll have to come back to that. And dy dt is -8. All right, so if you are missing something, what you need to do is go back to the original relationship and plug in what you have. And we have that x is 20. So I'm just going to do this as a side problem. This would be 225 plus 20 squared would be 400. Equals y squared. So this would be 625. And I made that come out to a perfect square for you. So square root of 625 is 25 for y. So that goes right there. And then your last step is just to divide over the 20. And you can reduce that if you want. There's no need to. It did come out negative like we were expecting. You can leave it just like that. You just need the units, which are feet per second.